Yes. All right. So we were discussing the lecture of getting started with machine learning. तो एक दफा मैं ओवरव्यू इसका कर देता हूँ आपको। उसके बाद हमारा मेन जो लेक्चर है वो आगे है। So why machine learning? Machine learning provides the powerful tools for solving the complex problems that may be difficult to address using the traditional programming techniques. एक रेपिटेटिव नेचर होती है मशीन लर्निंग की, वो भी काफी हेल्पफुल होती है एज कम्पेयर टू अदर एल्गोरिदम्स। अगर आपका एक दफा एक मॉडल अच्छा ट्रेन हो गया है और डाटा ड्रिफ्टिंग नहीं हो रही, डाटा ड्रिफ्ट का कॉन्सेप्ट होता है कि अगर डाटा में चेंजेस नहीं आ रहे तो वो मॉडल आपका फॉर द लॉन्ग टाइम उसी तरीके से आप उसको यूज कर सकते हैं और एक्सपेक्ट कर सकते हैं कि वो सेम किस्म की आपको आउटपुट्स देगा। अच्छा, आज का लेक्चर अगेन मोर लाइक डिस्कशंस होगा। आप लोगों के जो भी क्वेश्चंस हैं, आई रिमेम्बर जब हमने यही का टॉप स्टार्ट किया था ये वाला आपका कोर्स, तो उस टाइम आपके बहुत सारे क्वेश्चंस थे। तो टुडे इज द डे के आप लोगों के जो टर्मिनोलॉजीज हैं मैं वो डिस्कस कर रहा हूँ, मशीन लर्निंग के रिलेटेड इंट्रोडक्शन और इस तरह की चीजें। आज हम प्रॉपर कोई एल्गोरिदम इसका स्टडी नहीं करेंगे, हम अगले लेक्चर से करेंगे। तो आपके माइंड में अगर कोई क्वेश्चंस हो तो आप लोग पूछ सकते हैं। उसके बाद आपके पास है वर्सटैलिटी अक्रॉस द इंडस्ट्रीज। चाहे आर्टिफिशियल इंटेलिजेंस है या मशीन लर्निंग है, ये इटसेल्फ भी ऑफ कोर्स थ्योरेटिकली भी आर्टिफिशियल इंटेलिजेंस और मशीन लर्निंग में काफी इंप्रूवमेंट्स हो रही हैं, काम हो रहा है। डे बाय डे न्यू एल्गोरिथम्स आ रहे हैं, न्यू मॉडल्स आ रहे हैं या इम्प्रूवमेंट्स हो रही हैं, उनकी ऑप्टिमाइजेशंस हो रही हैं, एक्यूरेसी इंप्रूव हो रही है, कंप्यूट पावर रिड्यूस हो रही है, एफिशिएंसी, इस तरीके की एडवांसमेंट्स हो रही हैं। लेकिन अगर रियल इम्पैक्ट आप देखना चाहते हैं मशीन लर्निंग का या आर्टिफिशियल इंटेलिजेंस का, तो आप उसको किसी अदर क्रॉस डोमेन के साथ इंटीग्रेट करेंगे। फिर चाहे वो फाइनेंस है, वो बैंकिंग है, ठीक है। बैंकिंग में बहुत सारे ऐसे अभी भी यूज केसेस हैं जो कि जिनमें अभी एआई यूज नहीं हो रही और होनी चाहिए, ठीक है। फिर मार्केटिंग में यूज हो रही है, फिर आपकी हेल्थ केयर में, मतलब एजुकेशन में, ठीक है। टेक्सटाइल इंडस्ट्री में बहुत बड़ा यूज केस है, आपकी रोबोटिक्स में बहुत बड़ा यूज केस है, डिफेंस में बहुत बड़ा यूज केस है, आप लोग देख रहे हैं ड्रोन्स और इस तरह की चीजें। सो मेरे ख्याल से कोई भी डोमेन अगर आप उठा लें, हाँ ये जरूर होता है कि किसी डोमेन में बड़े क्लियर, बड़े ऑब्वियस किस्म के यूज केसेस होते हैं एआई और मशीन लर्निंग के, इसलिए लोग क्विकली अंडरस्टैंड करके अडॉप्ट कर लेते हैं। लेकिन कुछ फील्ड्स में आपको, जब तक आप उस फील्ड को प्रॉपर अंडरस्टैंड नहीं करते, उस फील्ड के एक्सपर्ट नहीं होते, तब तक आपको उस फील्ड के अंदर एआई का यूज के समझ नहीं आता। हाँ ये डिफरेंस जरूर होता है। डेटा ड्रिवन डिसीजन मेकिंग, मशीन लर्निंग ऑफ कोर्स डेटा के बगैर लर्निंग नहीं है, ठीक है। इवन अगर हम ह्यूमन नेचर को देखें तो इंसान वक्त के साथ साथ जैसे जैसे बड़ा होता है, उसका उसका सोचने का अंदाज चेंज होता है, ठीक है। ये सारी चीजें उसको किस वजह से पता चलती हैं? जो उसके लाइफ के एक्सपीरियंसेस रहे होते हैं, जैसे जैसे वो बड़ा होता जाता है, चीजें देखता है, ऑब्जर्व ऑब्जर्व करता है, सीखता है, उसको हम डाटा बोलते हैं। उसके माइंड में एक कंप्लीट डाटा होता है, ठीक है। उसके जो भी एक्सपीरियंसेस हुए होते हैं उसको सेव करता जा रहा होता है एज अ मेमोरी। ह्यूमन माइंड के अंदर ये चीज बाई गॉड है, ठीक है, नेचुरल है, गॉड गिफ्टेड है। इसी तरीके से जब हम कोई मशीन लर्निंग का मॉडल ट्रेन करते हैं तो उसकी लर्निंग किसी डाटा से होगी, और वो डाटा क्या होगा? वो पास्ट एक्सपीरियंसेस होंगे, ठीक है। पास्ट एक्सपीरियंसेस को ऑफ कोर्स हम किसी शेप में, किसी फाइल में या किसी भी फॉर्मेट में स्टोर करेंगे और उनको फिर यूज करेंगे। वो हमारा डाटा होगा, उसको उसकी बेस पे फिर हम मॉडल की लर्निंग करेंगे। इनोवेशन बाय लर्निंग द मशीन लर्निंग यू कैन कंट्रीब्यूट, हम, और जिस तरह हमने बात की कि बहुत सारी ऐसी इंडस्ट्रीज है जिनमें अभी भी एआई के यूज केसेस आपको एक्सट्रैक्ट करने पड़ते हैं कि आप कैसे उसमें एआई को कंट्रीब्यूट करवा सकते हो। तो आपके पास जो इनोवेशन है, इसको हम इनोवेशन बोलते हैं, यानी कि जो भी डोमेन है उस डोमेन के अंदर आप अगर कोई चीज एआई से ऑटोमेट कर रहे हैं तो उसको हम इनोवेशन कह रहे हैं। कैरियर अपॉर्चुनिटीज ऑफ कोर्स बहुत हैं, अभी तो और ज्यादा बढ़ती जा रही हैं। तो related to career opportunities, the demand of AI and machine learning is growing day by day. Of course, अच्छे engineers की automation and efficiency, machine learning can automate the repetitive tasks. You know about this, chat GPT की कितनी efficiency है, जो आपके कोडिंग एजेंट्स हैं उनकी कितनी efficiency है, टू सॉल्व द रिपीटेटिव टास्क, आपका टाइम बचाने में, ठीक है, रिसोर्सेज में, हर तरह से, हर लिहाज से। कम्युनिटी एंड कोलैबोरेशन, जब आप क्रॉस डोमेन में जाके काम करते हैं ना, तो इसको हम कम्युनिटी कोलैबोरेशन कहते हैं। अगर मैं हेल्थ केयर में काम कर रहा हूँ, तो मुझे डॉक्टर्स के साथ या उस पर्टिकुलर फील्ड के एक्सपर्ट्स के साथ कोलैबोरेट करना पड़ेगा। उसके बगैर मैं, लाइक, या तो ये कि मैं उस फील्ड को भी सीखूं, ठीक है, अगर मैंने एआई का हेल्थ केयर में इम्प्लीमेंटेशन करनी है, तो मैं, मुझे साथ एमबीबीएस की डिग्री भी करनी पड़ेगी या कोई और जो भी डिग्री प्रोग्राम होगा, ताकि मैं उस प्रॉपर फील्ड को समझ लूं। या फिर ये हो सकता है कि मैं उस फील्ड के लोगों के साथ कोलैबोरेशन कर लूं, ठीक है, वो अपनी तरफ से बताएं, मैं अपनी तरफ से एज अ टेक्निकल पर्सन उनको गाइड करूं, तो हम मिलके कोई सोल्यूशन या कोई चीज डिजाइन कर सकते हैं। तो ये सारे यूज केसेस हैं हेल्थ केयर में। डिजीज को डायग्नोज करने के लिए यूज हो रही है एआई, पर्सनलाइज ट्रीटमेंट प्लान्स बनाने के लिए यूज हो रही है। बहुत सारे आपके एफआईपीज ऐसे होते हैं जो इवन इस तरह की फील्ड्स में होते हैं। आप अगर ग्रेजुएट डायरेक्टरी देखें तो आपको बहुत सारे प्रोजेक्ट्स मिलेंगे। फाइनेंस में फ्रॉड डिटेक्शन के लिए जो आपकी स्टेटमेंट्स या ट्रांजैक्शंस को मॉनिटर किया जाता है। इन्वेस्टमेंट डिसीजन प्लान करने के लिए, ठीक है, क्रेडिट रिस्क, यानी कि जब भी अगर आप कोई चीज क्रेडिट पे परचेज करते हैं, तो बैंक के पास आपका एक क्रेडिट स्कोर होता है हर पर्सन का। ई कॉमर्स में आपको जो प्रोडक्ट्स की रिकमेंडेशंस आती हैं, सप्लाई चेन्स, ऑप्टिमाइजिंग द सप्लाई चेन्स ब्लॉकचेन के थ्रू, फिर आप मॉनिटरिंग के थ्रू, लॉगिंग के थ्रू, ठीक है, प्रेडिक्टिंग डिमांड एंड सप्लाई का जो गैप है उसको प्रेडिक्ट करने के लिए। मार्केटिंग में भी, द स्पेसिफिक कस्टमर टारगेटेड मार्केटिंग technology, there's a lot of use cases, virtual assistants, images, speech, education, personalized learning, predicting the students' success, automating the grading or evaluation processes, generating assessments, many other use cases of the education sector. Manufacturing, चाहे वो टेक्सटाइल है, एनी अदर surgical instruments or any other kind of manufacturing industry, a lot of use cases. Telecommunication, human resource, then agriculture is a very big field of artificial intelligence. Many use cases are still going on. Energy sector, of course. Energy sector are kind of the environments, those are very critical for a human. Hazardous environments where the human life is in danger. Uh, you can say that, just think of as a fire extinguisher, as a fire brigade, a human versus a robot, and many other use cases where you can say that we prefer a robot over a human because the environment is very extreme. Transportation, environmental monitoring, supply chain, retail, real estate, sports is a very big field. In the old days, there were no score predictions, there were no kind of ultra edge detection type tools where you can see where you can take the reviews, or you can see the things in reverse section, and many other use cases in the sports industry. And then social sciences. So these are all the use cases of the machine learning. Is machine learning easy to learn? So I would say, of course, yes. If you spend some time and learn the theoretical concepts of the machine learning and then do the implementation, so of course, it is easy to learn. It is not that hard, particularly for a person that has already the background of technology as a computer scientist, as a software engineer, or whatever. Because programming is not a challenge nowadays, but the problem solving, the theoretical understanding of the problem domains are the most important things. These are the some of resources that you can use for the machine learning. Many other resources you can search on Google. These are just the quick starts. And then there are some of the books related to the machine learning. By the way, Andrew Ng is a very good person. I really like him and enjoying the listening. Basics of machine learning for beginners. So machine learning basically nowadays it is more like 4 to 5 different types of machine learning, but commonly we say there are two different types of machine learning: supervised learning and unsupervised learning. Supervised learning where we monitor or give the kind of a feedback to the machine learning algorithms during the training, and unsupervised learning where we cannot give any input with the data set from human side, and the algorithms learn the patterns and the similarities themselves. Machine learning features the automation, adaptability, generalization. Machine learning can automate the systems. It is adaptable. You can retrain your models for the new data sets. Generalization, yeah, this point is very important, by the way. Let me clear it to you. So just imagine you have written a program like for maybe alphabet pruning, right? For any game, whatever the rules or the conditions or the tree of that game is, you cannot give any different input that is that is not being handled in that program. If you will give that kind of input, the program will not accept that input or maybe throw you an error or exception that this is not the input that I am expecting, right? But machine learning algorithm is very interesting because it is a predicted kind of algorithm. If you give any irrelevant kind of input to the machine, if there are no validation checks, just like the websites, then this algorithm can give you a prediction. Yes, we can say, of course, the prediction will be wrong. Prediction could be wrong. Prediction could be 50% true. Prediction could be 100% true. Prediction could be just 10% true. But this machine learning algorithm will give you some kind of output. This is called the generalization capability of the machine learning algorithms because these are not very task specific. Again, if we are looking for better accuracies, then yes, we can train our machine learning algorithms for specific tasks. These two things are trade-off with each other. The generalization ability and the kind of, you can use the word maybe, accuracy or efficiency of the machine learning algorithms. If you want more generalization, you need to compromise a little bit on the accuracy side of things. मैं आपको एक और से अगर इसकी एग्जांपल दूं तो ये हो सकता है कि एक पर्सन है, मे बी इन आइडियल सिनेरियो इट वुडंट बी, बट you can relate. The person, you have been heard a very famous proverb that is called, yeah, jack of all trades and expert of none. Yes. So what does this mean? एक बंदा है, उसको उसको 5-10 फील्ड्स में उसने लेट्स से पीएचडी की हुई है, ठीक है, उसको 5-10 फील्ड्स का आइडिया है। उसके पास किसी एक फील्ड का स्पेशलाइज्ड नॉलेज होने के चांसेस कम है, और एक बंदा है कि उसने 10 साल 20 साल एक ही फील्ड में लगाए हुए हैं, तो एक ही फील्ड में काम कर रहा है, तो उसके पास उस जितना नॉलेज उस फील्ड का स्पेशलाइज्ड पर्सन के पास है, जितना एक्यूरेटली स्पेशलाइज्ड पर्सन आपको रिस्पॉन्स दे सकता है, उतना एक्यूरेटली एटलीस्ट वो बंदा नहीं दे सकता जिसके पास क्रॉस डोमेन और द मल्टीपल जनरलाइज्ड नॉलेज है। तो दिस इज लाइक this type of concept of generalization for the machine learning models. Then we have the prediction and forecasting. So of course, after training, we do the prediction from the machine learning algorithms. That is why we are training them. Then real-time processing. Some machine learning models can process the data and make the real-time predictions. And then pattern recognition. Machine learning excels in recognizing the patterns and trends within the data. So these are some of the concepts famous in the machine learning: data pre-processing you will be doing in your lab, regression, classification, clustering, association rule learning, reinforcement learning, then NLP, deep learning, and so on. These are the concepts. Which libraries should I learn? So we mostly use NumPy, Pandas for data handling, data reading, data processing, and other libraries, scikit-learn for the machine learning algorithms, for simple machine learning algorithms, and PyTorch for deep learning algorithms, TensorFlow for deep learning algorithms, and the other libraries like Keras, Matplotlib for visualization, and Theano. These are some of the libraries that you will be using for your machine learning algorithms. Companies using machine learning algorithm, I think there is no need even to discuss this. Nowadays, every company is almost using the machine learning. We have discussed this slide in the very beginning of our course that artificial intelligence is a very generalized field. In artificial intelligence, there is machine learning field, and within machine learning, we have a deep learning, and now you can say within deep learning, you have the generative AI and agentic AI and many other fields as well. So that's it from this getting started with lecture. Let me start second one. If there is any question on this, you can ask. Okay, so this is now a kind of better lecture overview, complete overview of the machine learning algorithms and the process. Okay, so we have a data that we need for any machine learning algorithm. We will input our data to the machine learning algorithm. There is a difference between algorithm and model. Machine learning algorithm and machine learning model. What's the difference? Anyone of you would like to input? What's the difference between machine learning algorithm and machine learning model? No? Anyone? Yes?
एल्गोरिथम जो प्रोग्राम होता है और मॉडल मेरे ख्याल से जो वर्किंग में होता है जो मतलब हम यूज करते हैं
Somehow, yes. So मशीन लर्निंग एल्गोरिदम हम उस टाइम वर्ड यूज करते हैं उसके लिए जब हम उसको प्रोग्राम कर रहे होते हैं, ठीक है। सो जस्ट कंसीडर इट लाइक इट कि आपने एक प्रोग्राम लिखा है पाइथन में, ठीक है, एंड दैट प्रोग्राम इज दिस वन जो यहाँ पे मेंशन भी हुआ हुआ, ठीक है, यहाँ पे जिस तरह कंप्यूटर आपको नजर आ रहा है, दिस इज योर एनी प्रोग्राम, and this program of course reads a file, maybe a CSV file or the Excel file for the dataset, and then uh, there is a lot of code in this program and it process this data and then train a model on this data, do the training iterations, learn the patterns and many things. वो अंदर क्या क्या करता है वो सब हम of course आगे आने वाले steps में देखेंगे. But after that, once this particular program or the algorithm has done the complete overview or the understanding or the training of this data set, we will use this algorithm now for prediction, right? We will give this algorithm here, we will use this algorithm here, we will give the new data set, and on the basis of the the patterns this algorithm extracted from this previous data set, on the on the basis or on the knowledge of these patterns, the new data set will be given as an input to this particular algorithm, and it will give you the more patterns or the new outputs. So you can say the difference is when our machine learning algorithm is in kind of a program format, we call it machine learning algorithm. And when it is in a trained format after the training, we call it the machine learning model. एक्चुअली जब आप इसको लैब में इम्प्लीमेंट करेंगे तो आपको मजीद क्लैरिटी इस पे मिलेगी बिकॉज what we usually do is from a machine learning algorithm we most of the times export a trained model and there is a different file for the trained model. So most of the times we export or the save the trained model in a different format, and in the time of inference or for a new data, we use the that trained model for the inference. Or inference is the word that we use for the prediction of new data sets from the trained model. It's called actually the inference. So what is the difference between a normal algorithm and machine learning algorithm? So normal algorithm is set of instructions. Very easy. Normal algorithm is set of instructions. For example, if we have to make kind of if we have to cook a chicken, and these are some of the steps that we will use. For example, we write a program in a sequence. First of all, it cuts the vegetables, then it seasons the chickens, then preheat the oven, then cook the chicken for 30 minutes and add the vegetable. Okay, so these are the set of instructions written in the format of a program. This is called normal algorithm. Normal algorithm of, you can say, any hardware. You have a machine and you have given these instructions to that machine. You will just input a chicken piece with the vegetables and start this machine. This machine will follow all of these steps and will give you this output. Just give me one answer. Can you can this machine cook this chicken for 28 or 35 minutes? No, right? Because this is a hard-coded algorithm, right? In the runtime, when you give this particular machine any input and run it, of course it will follow the instructions written in the program. And if in the program it is written that cook chicken for 30 minutes, it will cook it for 30 minutes, irrespective of the output or irrespective of the requirement to cook chicken for maybe 25 minutes, 20 minutes, 35 minutes, because this algorithm is not adaptive and not intelligent. Okay. Then in a machine learning algorithm, what we show to machine learning algorithm is this is the input. We have the vegetables and a piece of chicken, and this is the input, and this is what we are expecting as output. So we will give maybe 5, 10, 50, 100 samples as the input, output, input, output, input, output. And in those samples, of course, there will be a variety of inputs. किसी में चिकन का साइज बड़ा होगा, किसी में छोटा होगा, किसी में वेजिटेबल्स ज्यादा होंगी, किसी में कम होंगी. And according to that, this algorithm will actually learn how much the quantity of vegetable and the chicken needs, how much time to cook for 30 minutes or 25 minutes, right? Whatever you can say the average duration or whatever the best possible duration according to the input sample. The difference between normal algorithm and machine learning algorithm is, as a normal algorithm, it follows the predefined set of instructions. If there is any problem in defining the set of instructions, of course, program does not know about it. Program will follow the set of instructions. But machine learning algorithm, we show it the input and the output, and then after training of a lot of samples, machine learning algorithm actually got the understanding how to cook the chicken, how to make, how to use this input to make an output like this, and then after that it automatically figures out what to do. I have to cut the vegetable, then season chicken, then preheat oven, then cook chicken for 30 minutes, and then add vegetable and etc. So far and so far. So these are the uh, you can say kind of visualization of the steps that machine learning algorithm will follow. Maybe first time uh, it will burn your chicken because of uh, the more time for cooking or more heat, whatever you can say. Second time a little less burn, then more or less. Okay, so one thing if you notice here is a little bit variation in the second instruction of the program. You can see it here. Season chicken with lots of spice, season chicken with extra spice, season chicken with a little extra spice, and then season chicken only, right? So until or unless our instructions were not accurate, we were giving a feedback to the machine learning algorithm that we are not going to accept your this type of cooked chicken because it has a lot of spice. Then it figures out, okay, let me reduce a little bit. Then it added some extra spice. We still say no, we are not going to accept it. Then in the next step, it tries again and it say, okay, I'll add a little extra spice. We give the feedback, no, we are still not going to accept it. So on basis of feedback, actually, this machine learning algorithm is adopting its knowledge, adopting its instructions, you can say, or the steps. And once it sees that this output has been accepted, it means this sequence and this set of instructions is accurate. Now onwards, it will follow these kind of instructions and the steps because these are the accurate as compared to the normal algorithm. This is what machine learning algorithms do, and this is how actually machine learning algorithms works. Okay, now there is one point that should be cleared here. There are two options that you give this feedback. So one is runtime feedback. Give input sample, got the output, so give algorithm the feedback that you are going to accept it or not. This is what we call the reinforcement learning. And the second option is all these samples from 1 to 100 are from your past experience. So we have recorded our past experiences. हमने एक दफा चिकन को कुक किया, हमने मिर्चें ज्यादा डाल दी, सही नहीं बना. दूसरी दफा कुक किया, थोड़ी सी ज्यादा ऐड की, फिर भी सही नहीं बना. तीसरी दफा कुक किया, बिल्कुल थोड़ी सी एक्स्ट्रा डाली, फिर भी सही नहीं बना. बट हमने किया क्या कि हम इन एक्सपीरियंसेस को रिकॉर्ड करते गए अपने पास फॉर फ्यूचर यूज, कभी काम आ जाएगा. दिस इज व्हाट वी कॉल द डेटा सेट. ठीक है. If we have past experiences as a data set and we have the labels as well, these are actually the labels. This was the experience one, this was the label, it was accepted or not, chicken was cooked correctly or not. This is the second experience, and this is the label or output of the second experience. This is third. This is the third output. In the same way, you have recorded around 100 experiences and you have recorded the output as well. This is called the label. What was the output of the experience or the experiment? The benefit of this experiment is there is no need to interrupt or give the feedback on the runtime. There is no need of a human to be in the loop during the training. You can just give all these experiences and algorithm will figure it out itself. And this is what we call the first type of machine learning, supervised learning. Because these 100 experiences were supervised previously at some time by adding these labels. Because we are using this data that was supervised previously by any person, by recorded by any person, that is why we are saying that we are doing supervised machine learning. And this is called reinforcement machine learning, where we give the feedback to the algorithm in the meantime or the real time. And the third one is unsupervised learning. You have seen in the previous slide. Supervised learning, unsupervised learning, and reinforcement learning are the famous. There are some others I'm not going to discuss. You will be confused. Semi-supervised or self-supervised. But these two, three are the main. Supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, whenever you have a data set with the labels or with the feedback of any human or any other machine or the algorithm, whatever you can say. And reinforcement learning, when you give the feedback in the real time. And unsupervised learning, you have the data set, but unfortunately you did not added the labels. You have the 100 experiences, you have the 500 or the 1000 experiences in the past, but you are not able to add the label or the output or the outcome of each experience. If you use this kind of data set, it is called unsupervised learning, because now model will figure out itself on the basis of some patterns, some similarities, and do the groups of the data set. Of course, this seems to be a one group. When you added extra spices, little spices, more spices, this seems to be one group. And when you don't add any kind of spice, this looks another group. This is how actually the unsupervised learning model learns. I hope you got this point. Okay, let's move next. Data science is a field, you can say again, a broader field in which we use the machine learning. And data science, we have a lot of, as you see the name data science, it means there is a lot of data analysis, data understanding, data processing, data management, data storage, many other things going on under this definition of data science. And one of those is the data analysis. We do the data analysis before any machine learning algorithm. It helps us a lot because it helps us to understand the structure of the data set. It helps us to understand the data is with the labels or without the labels. So many other things actually data analysis gives us. Uh, Data has any noise, data has any ambiguous values, data has any null values, data has any uh, kind of outliers, many other things you get from the data analysis. So of course, data analysis is important before we train any machine learning algorithm. So what are actually the steps or the framework for, you can say, one complete machine learning framework? First of all, you do the data collection. This is what we were saying. Data collection is actually recording the experiences, right? And saving it somewhere. And you have seen there are two different options. Either you record experience with feedback, with which is called label, or you are recording the dataset without the human feedback or any other machine feedback. So that is going to be an unsupervised data. Data modeling is actually uh, the stage where you store data, where you analyze data, where you process data, and many other steps. And then deployment. These are the three main things. So data collection is part of machine learning. Most of the times we need to collect data, right? And then, of course, deployment is also the part of our technical side. As a developers, we do the deployments. And This is actually the data modeling stage. This is very important where we use the data. Okay, so how we use the data? First of all, by seeing the data set, by analyzing the data set, what we do is we analyze that what problem are we trying to solve using this data set. Actually, this question is something like this: what problem we can solve using this data set? ये सवाल बहुत इंपॉर्टेंट है, ये मैं आपको यहाँ पे एक दो पॉइंट्स और बताता हूँ. Sometimes when you're working in industry, you have been given a data set and you have been asked that, okay, this is the data set, go and figure out, uh, you are an AI engineer, right? Go and figure out how we can use this data set to solve this kind of problem. मैं आपको तीन तीन चार दो तीन डिफरेंट सिनेरियोज बताता हूँ क्या होता है, किस तरह से होता है. एक ये है, आपकी इंडस्ट्री है, आप किसी इंडस्ट्री में काम कर रहे हैं, उस इंडस्ट्री का कोई डाटा रिकॉर्ड हो रहा था. ऑफ कोर्स डाटा रिकॉर्ड होता है, मोस्टली इंडस्ट्रीज का होता है, डेटाबेस में पड़ा होगा या किसी जगह पड़ा होगा. दे एक्सट्रैक्टेड द डाटा सेट एंड दे गेव यू द डाटा सेट एंड दे आस्क्ड यू, go see this data set, understand this data set, and we need to solve this problem using this data set. So what does this mean? The problem is defined, okay? Problem is very clear. Whatever problem industry needs to be solved. They are saying you go understand this data set and then solve this problem using this data set. No, you have, if you are a good data analyst, if you are a good machine learning engineer, at this stage, you will clearly see that the problem that they are giving me can be solved using this dataset or not. Otherwise, you will waste 2, 3 months, maybe 6 months, maybe 1 year, and end up with nothing. Because the problem that they were giving to you cannot be actually solved using this type of dataset. Okay, what is the second thing? Second thing is sometimes industry don't have the clear definition of the problem. Industry can say you, okay, we can give you the data set as an AI engineer or as a scientist. It is your job. Can you go and understand this data set and propose us some of the automations or some of the solutions that we can develop for our organization using this data set? Then this is even more difficult. Okay, so you need to be very creative, you need to be very problem solver, and you need to be very analyst kind of person at this stage. You need to analyze the data. You need to think of, okay, this is the data I have, this, what I can use and how we can automate. Okay, how this data could be helpful to develop any model that could be helpful for the maybe prediction, for the forecasting, right? For the risk measurement of my company. This is crazy. And the third option could be they gave you a very clear data set and a very clear problem definition. No, it is just your job to program it and train the model. And believe me, in the real world settings, this third option is very rare. Okay, so hopefully you understood the problem definition step very clearly, and data as well, of course. Okay, because data is the thing that defines either we can solve this problem or not, and problem is actually the thing that we can define using the data set. There are a couple of things that I should mention here. Yes, sometimes we use the given data set, and using that data set, we do some statistical methods or we do some mathematical operations, and we calculate some new variables or the new features using the given features, right? And those may be helpful to solve that particular problem. You will see these things maybe in practice and you will get the better idea. The third thing is the evaluation. Okay. Evaluation is actually okay. We understood that we can use this data set and we can solve this problem, but how we will evaluate our solution, right? Evaluation is very important. How we will evaluate that either we have solved this problem accurately, efficiently, or not. So the definition of evaluation criteria or the success criteria, how my company will accept my solution, right? So this is called the evaluation metrics or the evaluation criterias. You need to define this in the very early stages because uh, if the evaluation criteria is not defined, you're going to suffer. Okay. If the evaluation of the success criteria of machine learning model is defined clearly, this is going to be easy for you. Okay, this is the data set. This is the problem that I'm going to solve using this data set by training a machine learning model. And this is what my benchmark or my threshold or my passing criteria, the evaluation criteria is, on which I will evaluate my solution. And if it is passed, okay, I will accept it. And then we have the features engineering stage. This is kind of, you can say, feature engineering or the data processing stage. Here we do is we kind of take the data set and we apply different data processing techniques and different feature engineering techniques. The purpose of this step is very clear and very important because, for example, you have a very big data set. I'm just taking as an example. You have a 1 TB data set given by your organization, and it has a lot of features, thousands of features. Okay. This is not necessarily meant that you use all these features and all this data to solve the problem. This is where the feature selection and the feature engineering part comes in. कंपनी के पास डाटा था, उन्होंने उठा के दे दिया पूरा 1 TB का, उसमें थाउजेंड्स ऑफ फीचर्स हैं, उन्होंने बता दिया ये वाला प्रॉब्लम सॉल्व करना है और आपने सारे का सारा डाटा उठाया एज इट इज और सारा मॉडल को दे दिया, बस ठीक है खुद ही करो जो करना है। ऐसे नहीं होता। We need to see for this particular problem, out of all of the values that are available, we call it all of the features, all of the variables, all of the fields, whatever you can say, available in this data set, which fields are more important or which fields are sufficient enough that I can use and solve that problem. There is no need to use all the features. Nothing, I mean nothing. Sometimes even you will get the better results by using less number of features as compared to more. The more features mean more computation. More computation requires a lot of resources and a lot of time to train a model. So the good engineer is the one that actually इसका इम्पैक्ट आपको तब नजर आएगा जब आप एक मॉडल एटलीस्ट अपना ट्रेन करके किसी रियल वर्ल्ड एप्लीकेशन में इंटीग्रेट करेंगे, देन यू विल रियलाइज हाउ मच इंपॉर्टेंट इज द फीचर सिलेक्शन because for example you have 1 2 3 to so on 50,000 experiences recorded, the 50,000 samples. Okay, out of the 50,000 samples you have feature 1, you have feature 2, you have feature 3, feature 4, right? Now just imagine if you figured out that if I can train a model without using the feature 2 and it is giving me the equal results when I was using all the 4 features, and when I am using F1, F3 and F4 it is giving me the equal results, then what's the need of feature 2? And just imagine the scale of feature 2. A feature 2 variable maybe was taking 8 bits, one value, and there was 50,000 values extra. And you passed this data set to machine learning model for training, and you did training for 1000 number of iterations. Now just multiply the numbers. Because of course model will not get trained if you pass on all the 50,000 experiences one time. You have to pass it again and again. You have to run this loop. This is called the training loop. Maybe you need to run it for 1000 times. You can calculate the space utilization and the compute power utilization. And then once this model is trained, this model will require the feature 2 for the inference time. Inference time means for the real time usage of this model. अगर आपने फीचर 2 भी इंक्लूड करके ट्रेन किया था तो, लेकिन अगर आपने फीचर 2 को निकाल दिया था, आपने 3 फीचर्स पे ट्रेन किया था एंड यू गॉट द इक्वल रिजल्ट्स, देन यू नीड ओनली 3 फीचर्स फॉर इवन द रियल टाइम inference time. Okay, so next we have the modeling stage. So modeling is basically, this is actually now you are at the programming stage. You are programming a machine learning model, you're writing a code, uh, you have figured out that I will use this data set, I have to solve this problem, I need to evaluate this problem's result on this evaluation matrix, this is my benchmark, I will be using these features. Now you will write the algorithm, now you will write the code of your machine learning algorithm. Complete it, and then this is the step for experimentation. This is what I was saying to you. Maybe you implemented one experiment and you run this machine learning algorithm for 100 times and it gave you, let's say, 80% results. Okay. Next time you run it for, let's say, 120 iterations. Yes. Any question? Okay. Next time you run it for 120 number of iterations, it gave you 85% results. Next time you run it for, let's say, 150 number of iterations, and it gave you 90% results. Right? This is what we call the experimentation stage. Because at experimentation, we try a lot of different combinations. Okay, and we did a lot of experimentations. We try evaluation metrics and we evaluate whatever the best fine tuning of our model is, where we are getting the best possible results using the best possible features. That will be the kind of the final experiment, and we will consider that parameters are of the model as a success. Any question on it? क्योंकि ये आगे ये यूज होना है सारा हर जगह. Okay. So this is the problem definition. मैं आपको पहले ही बता दिया था. Supervised learning, unsupervised learning. On the basis of problem definition and data set, you will get to know कि मैंने क्या यूज करना है. ठीक है, सुपरवाइज लर्निंग करनी है, अनसुपरवाइज लर्निंग करनी है, माय डाटा इज लेबल्ड और नॉट, माय डाटा इज विद लेबल्ड और नॉट. Okay, and which algorithm I need to use. These two are the types of supervised learning algorithms: classification and regression. We use classification for discrete labels, for the discrete outputs, and we use regression type of algorithms for continuous outputs. Okay, if you have a classes, you will use classification algorithm. For example, I need to predict if I give the symptoms of a patient, I need to check that which disease this patient has. I will use classification type of algorithm of machine learning. But if I am giving, for example, a house parameters as the input and I am expecting that this model will give me the predicted price of this house, this is called the regression algorithm, which is because price is a continuous variable. Okay. And then data set, if the data set is very structured and if the data set is unstructured. These are the two different values. If data set is in CSV or in Excel sheet, Of course, it is structured because it is a tabular format of the data set. If you have a data set where we have images, audios, and many other format, it is called the unstructured. Other documents, it is called unstructured data set. Evaluation metrics, success criteria. I have already discussed with you. You will give the input. This is your trained model. This is the trained model's output. You need to evaluate your trained model's output on the basis of some evaluation algorithm metrics. This is called the evaluation criteria, the metrics. This is the feature. For example, if you are predicting that this person has heart disease or not, so we have features like ID, weight, sex, blood pressure, chest pain. These are all the uh, features that are available to us and we can use to train our model. But we need to check that which features are important for the heart disease. So for heart disease, maybe the ID feature is irrelevant. There is no importance of ID. It is only representing a unique patient. There is no dependency of ID on the heart disease. Okay. Blood pressure could be important. Weight could be important. Chest pain might be important. Okay. Then modeling, for example, we will try for this problem model 1. This is another model. For problem 2, we will try another model. This is modeling, the programming of the models. The multiple options that we have, we will try to get the better results. I have discussed experimentation. You will do a lot of attempts or experiments until or unless you get the better results. We have seen this problem, the chicken cooking problem. So these are the types of the machine learning. I have already discussed with you supervised learning when you have the data sets with the labels, with the feedback. And reinforcement learning when you are getting the feedback in the meantime, in the real time. Unsupervised learning when you are training a model on the data set that don't have any kind of labels. Transfer learning is a different thing. For now, okay, I will give you just an overview that you trained a model on one thing and you are testing it on the other thing. And the supervised learning, we have discussed this. This is the data. These were the instructions given to cook the chicken. This is the label. Chicken was not cooked better. And this is the label. Chicken was cooked better. So of course the algorithm will prefer this one in the prediction. Supervised learning has two further subtypes, the classification and regression. I have discussed with you that if your problem is discrete, we will use classification. If our problem is predicting the continuous values, we will use regression type of algorithms. Unsupervised learning when we don't have the label or the output. Okay, this is called the unsupervised learning. Label is missing, there is no label. Transfer learning is a different type of machine learning algorithm. Reinforcement learning, we have discussed this. We will use that if we score it positive or negative. We are giving actually the feedback, human feedback and the machine feedback during the training time of the algorithm. And then, okay, this is the data about data. This is structured data. We have a very structured tabular format of data. This is unstructured data format. Different types of data, of course, data could be in CSV, data could be in Excel, data could be in text documents, in images format, many other formats of the data sets. Real-time data, we are getting some streaming data sets. So you are getting a data, you are pre-processing the data using the Pandas library, you are doing the data analysis, and then through visualizations, and then you are training a model, and then you are evaluating and predicting a model. What data you can use is depend on problem actually. Okay. So now these are the actually evaluation metrics example. what we were saying, that how we will evaluate our model, that it's accurate or not. So for regression, for the continuous type of models, we will use the mean absolute error, actual value and predicted values difference. Okay, and then for precision, we use in the case of classification, and in case of regression, we can use mean squared error, the difference in the format of square, and then root mean squared error. These are the continuous values, the regression algorithms evaluation metrics, and these are the discrete values evaluation metrics when we do the classification. Accuracy, output was 1 and the actual value was 2. Okay, output, the predicted output is heart disease, yes, and the actual value was no heart disease to this patient. So classification accuracy is actually predicted versus the accurate value. Precision and recall, these are the evaluation metrics for the classifications, and these are the evaluation metrics for regression, the difference, the values. So, for example, classifying the car insurance claims, if we are doing a car insurance claim, this is the ID, this is the image of the car accident, this is the text description of the car accident. Result, we have trained a model that actually predicts that the driver was at fault or not, so that we should claim its insurance or not. If driver was at fault, we will not claim the insurance. If driver was not at fault, we will claim the insurance. So what kind of algorithm you will use in this example? You need to predict that driver was at fault or not. This is classification or regression. Of course, this is a binary value, so we will use the classification algorithm. Again, this is different features of the data sets. You have multiple examples of the data sets just for your understanding. You can go through it. There is no need to see this because this is more like for the deep learning. This is the example of what features should you use. This was the redundant feature that was removed. There was no need to even add this feature. In the feature engineering step, we discussed that we will remove unnecessary features to avoid the extra computations. Okay, choosing and training a model, then fine-tuning a model, then model comparisons. This is experimentation step. This is the modeling step. This is the problem identification step. Then we divide actually our data set in three different subsets. So one subset for training of the model, one subset for the validation of the model, and one subset for testing of the model. I will discuss with you the validation and test difference in later class, but I think you can clearly see the difference between training and testing. We will use training data during the training of the model, and we will use the test data for the testing of the model. Okay. So the most important concept in the machine learning is the three sets. Course material is your training set. Practice questions is your validation set, you can say, and the final exam is your test set that is completely unseen to you, given you at the end of the semester once you are completely trained. Usually we use this ratio for the subset splitting, 70% of the data for the training, 15% for the validation, and 15% for the testing. But it's not the uh, kind of hard thresholds. You can tweak with this. And in the experimentation step, of course, for problem one, we use the model one. For problem two, we use the model two. We do the experimentation of different algorithms. You can see we trained an algorithm. The first experiment gave us 87% accuracy. The training time was 3 minutes. The second experiment gave us the 91% accuracy. The training time was 92 minutes. And the third experiment gave us the 94% accuracy and the training time was 176 minutes. Now it's on us that for us the training time is important or accuracy is more important. If accuracy is more important, of course we will prefer the model number 3 because it is giving the highest accuracy. If the training time, we need less training time, we will prefer 87%, 87.5%. Of course, we need to compromise on maybe 7 to 8% of accuracy. It depends on situation. Situation to situation, we our choices varies. In medical, we cannot compromise even 0.7% on the accuracy. We have done this, tuning a model, comparison, training set. That's it. Yeah, this is something else that we will see in our next lecture, overfitting and underfitting. Until now, that's it from my side. If you have any questions, you can ask me.